So we talked about properties and how we can identify different kinds of matter, but how does the matter change? There are physical and chemical changes. So physical changes are often related to physical properties. One example of physical change, which I've been talking about, is state changes, transformations from one state to another. There were 3 states, solid, liquid, gas, changing between them in any combination, always a physical change, always physical. When we have a physical change, the matter changes its appearance, but not its composition. When ice melts, it looks different, but the composition of the ice is the same. They're both composed of water molecules. In a chemical change, the matter does change its composition. Our neighbors built this awesome house next door, which is great because it makes our house more valuable, right? It's always good to own the smallest, least fancy house on the block because then you get more value for it. Anyway, we got this big, beautiful house next door, and they have copper on one of these little, I don't know what you call them. Part of the roof has copper on it. And when they first put it on there, it looked like a brand new penny. But now it's got this patina on it, right? It's kind of this greenish color, which is what they wanted. What happened to that copper? Well, the continued exposure to air causes a new compound to form on the surface of the copper. It's copper's version of rusting, except it doesn't rust through like iron does. But it's not pure copper anymore. It's copper combined with oxygen. That was a chemical change. So when matter undergoes a chemical change, we call that a chemical reaction. Chemical reaction, chemical change, same thing. Different names for the same thing. In a chemical reaction, you have substances that turn into something else. The substances that are present at the beginning are called reactants, and the substances present after the change are called products. And so we write a lot of equations, and we start with the reactants. Just like we read left to right, we write these in this order, starting with the reactants, ending up with the products. And it's important to understand reactants are on the left of the arrow, products are on the right. And these words give you a clue. The reactants react to produce the products. Okay. We see the difference between chemical and physical changes at the molecular and atomic level, which is not something we can see with our naked eye. And so that's why we have to use a little bit of common sense when we try to identify whether these are physical or chemical changes. You can have something change its appearance even though the particles haven't changed. You have an ice cube and it melts. It looks different now, doesn't it? But the particles are still the same. In a chemical change, the atoms or the molecules change their fundamental associations and you get a completely new substance. A physical change, we're going to have a different form of the same substance, and in a chemical change, we're going to get a completely new and different substance. So here's an example of a physical change. This is a lighter, and if we push the button without actually igniting it, what happens is the butane will go from its liquid state inside the lighter, and it will begin to escape as a gas. And here we've got the little molecules illustrated to help you see what's going on. These little butane molecules here and the butane molecules there are exactly the same, but what's different is that one's in a liquid form and one's in a gas form. This is a physical change, not a chemical change. Has it changed its appearance? Yeah, it's in the gas form now. It looks invisible. It doesn't have an odor. You can't see it. It looks like it disappeared. But those molecules are still there, and they haven't changed. If you flick the Bic and get a spark, you're going to have combustion occur. That's the purpose of having a lighter, right? Is to make little fires. Well, this is the butane burning, and it burns to form carbon dioxide and water. Do we have any butane left after this is done? No. We have new substances. The butane burned, and it formed carbon dioxide and water. It changed into new substances. This is a chemical change. It's a chemical reaction. Any questions? So we should be able to answer questions like this, except some of these are a little obtuse, and I'll make them more obvious on the exam. The rusting of iron, chemical. The evaporation of fingernail polish remover, which is acetone, from the skin, physical. What's the clue? There's a word in there that's a clue. Evaporation. This is the name of a state change. Any state change is physical. The burning of coal. I'm hearing physical. It's chemical. When something burns, we get new substances. Think about a log in the fireplace on one of those rare days when it's actually a burn day and you're allowed to light the fireplace. You burn the log, and what's left afterwards? Ashes, right? Is it the same substance? No, it has changed. Anytime you see burning, combusting, something like that, that's a chemical change. Burning is always a chemical reaction. Now this one is a little bit vague. The fading of a carpet upon repeated exposure to sunlight. Like, well, is that physical or chemical? So if you said physical, why? What makes you think physical? You're not changing the carpet, you're just changing the color of it. That would be a decent argument for saying it's a physical change. And like on a lab report, where it's not multiple choice, I would accept that. It probably is actually a chemical change because the substances that give color to the carpet are actually chemicals. And when they lose their color, it's because some sort of a reaction has happened to them and they have now become colorless. So this one, I will say that's arguable. We could argue about that one. That would not be a good exam question. We can use physical changes to separate mixtures. This is an example of distillation. Distillation separates liquids based on differences in boiling points. So here we've got a mixture in here of liquids, and we heat it up, and the substance with the lower boiling point will boil first and go into the gas state. Now, we're not going to just let it escape into the atmosphere because we want to keep it. So we've got it trapped here, and we're forcing it to come through this tube called a condenser, which is a double-walled tube, and it's got cold water running through it. So when this vapor hits this cold tube, it's going to condense back into a liquid and run down in here into the receiving flask, and we'll capture it that way. And then what's going to be left over here is the liquid that has the higher boiling point, because we're not going to heat it high enough for this liquid to boil. So we can use difference in physical properties, the boiling points of these liquids, to separate them. There's no chemical changes that have occurred here. The more volatile liquid went from a liquid to a gas, that's a physical change. And then here it condensed from a gas into a liquid, another physical change. You can do that with mixtures. You can't do that with compounds. Filtration. So here we have a mixture of a solid and a liquid, and we pour it into a funnel, and there's some filter paper in here. This is a lot like making coffee. You mix coffee grounds in hot water and pour them through a coffee filter, and liquid comes through and the coffee grounds stay behind. One is a solid, one is a liquid, and we can separate them based on differences in their physical properties. Any questions?